Okay, welcome back. So last time we treated the general methods of differentiation, and today we are going to look at the first principle method of differentiation. All right. Before I go ahead, I have defined differentiation as a process that deals with what a change of variable with respect to another variable. All right, that's what differentiation is all about, and we're looking at first principle of differentiation today. Okay, please just stay. Let me give you a particular example that you solve, and you will be well acquainted with the method I'm going to show you now. Okay, so we have first principle of differentiation. First, for you to validate your answer, it's always advisable that whenever a question is given to you, that you are instructed to apply the first principle method, you use the general method to know whether if the answer you're going to get is the right answer you're expected to get. Okay, what do I mean? When you have y equals what? X squared. So you have to solve this particular question or differentiate this particular question using the first principle method. You may know what to do, but for you to know that you did not make a mistake along the line while solving the problem, it's advisable that you apply the general method, which states that y is equal to s raised by n. Then when it's differentiated, we'll have it that the y over what the s is the same, is equals to then ns raised by n minus 1. Then if we apply this method to solve this, we are going to have y equals to x squared, where this will now give us dy equals to ds being 2 come down, which is 2s raised by what? 2 minus 1 being what? 2s as the answer. This implies now that when you apply the first principle method of differentiation, you are going to get 2s as your answer. All right. So let's go ahead to solve with this particular example and see what we have as our answer at the end. So when you are given this, you say solution. You introduce what we call changing x and changing y, which is changing x, we also introduce changing y. This is the type of change in x and change in y instead of dy over ds that are being used in terms of first principle differentiation. Now, having introduced this, the next thing you do is to add it to any of the side. Let's say we have y here, we'll add change in y. As we have x, we'll add what? Change in what? X. Okay? So it implies that we say let y equals to what? Y plus what? Change in y. Then let x equals to what? X plus change in x. That's my statement. So wherever you see y, you're going to add this. Wherever you see x, you're going to substitute what you're seeing here. That's the first step you're going to take in order for you to solve this problem that is given to you. Okay, having done that, you can now say y here can now have y plus change in y is equals to, then x here should be x plus what? Change in x. Then remember x is squared, so we have to what? Square it. Okay, y equals to y plus change in y, s equals to s plus change in x. So let's leave this side and work on this side. We have squared here. So can I say s plus change in x, then multiplying s plus change in x. This can give us s multiplied by s is s squared. S multiplied by change in s is x change in x. Then change in s multiplied by s is x change in x. Then change in s multiplied by change in s, that will give us change in what? S squared. And adding these together, you have s squared plus 2x change in s plus change in x squared. All right. So this is the product we got from this. So now we can now write y plus change in y is equals to, the value we got here is s squared plus 2x change in x plus change in x squared. So what next are we going to do? We already have this. What you do now is make change in y the subject of the formula. So now, to do this, y has to go to the other side of the equation. And remember, whenever a number is crossing the sign of equality, the sign changes. If it's positive, it changes to minus. Then if it's negative, it changes to what? Positive. All right. So s now being a plus, having a plus sign, will change to this minus sign when it crosses to this side of the equation. And that will have change in y equals to s squared plus 2x change in x plus change in s squared minus y. So now, remember, from the given question that y equals to s squared. So we can now substitute the value of y in place of y here. And if we do that, we are going to have change in y is equals to s squared plus 2x change in x plus change in s squared minus what? S squared. If you look carefully, you will understand that s squareds need to cancel each other, where we have positive s squared going against negative s squared. And that will have this remaining. Change in y equals to 2s change in s plus change in s squared. So what we'll do now is we can take their common factor, which will have change in y is equals to what they have in common. They have change in s in common. Can I say change in s bracket 2s plus change in x, such that if you use to multiply this, you get this back. If you use this to multiply change in s, you also get this back. Then what do? We divide both sides by changing s, which will give us divide by changing s divided by what? Changing s. This can go against this. Remember, when you were given this question, they will tell you as changing s tends to 0. Okay, that's how the equation is going to look like. So changing y over changing s is the differential form that we are looking for. And we have got that to be changing y over changing what else as being equals to 2s plus what changing else, which is 2else plus what changing else. Remember, changing else is, let's say it tends to 0, means it is what 0. And if it's 0, it means what we are going to have is change 2s plus what 0, which is equals to what 2s as our what answer. And that's what we got when we apply the general method to solve this. So this is how we solve it. Please, if you are not interested in this particular solution, make sure you check other ones. That is chains rule, product rule, quotient rule, and implicit differentiation. I'm going to drop all the solutions. Thank you.